Well, the question says the distance between Joe's house and the supermarket is X kilometers. He drives from his house to the supermarket at an average speed of Y kilometers per hour. From the supermarket, Joe returns to his house along the same route at an average speed of Y kilometers at an average speed that is 1.5 times faster than the original average speed of Y kilometers per hour. Calculate the overall average speed at which Joe drove from his house to the supermarket and back. Leave your answer in terms of Y. All right, this is a words problem. So I'm going to, because of space, I think I'm going to paste the same problem over here. Just move this one. I'm going to paste the column here. So we have that question 1.3. All right, the question says that the distance between Joe's house and the supermarket is X kilometers. So assuming that the distance is this from Joe, and Joe's house is somewhere here. Okay, Joe's house, and the supermarket is over here. Now, this whole distance is about X kilometers. Okay, and now that's what the question says. So the distance here is X kilometers. Now, the question says also, he drives from his house to the supermarket at an average speed of Y kilometers per hour. So the speed will be that from his house to the supermarket of Y kilometers per hour. So now the speed from the house to the supermarket, Y kilometers per hour. Now the question also said, from the supermarket, Joe returned to his house along the same routes at an average speed that is 1.5 times faster than the original speed of Y. So 1.5 faster, so meaning from the supermarket to his house, 1.5 times faster, so 1.5 Y, okay, kilometers per hour. Okay, so that's what the question says here, 1.5 times faster than the original speed of Y kilometers per hour. This means 1.5 kilometers per hour. So we can write it 1.5Y. We can write it as a fraction. It's going to be like 3/2, okay, kilometers per hour. Now, the question says then, calculate the overall average speed Joe drove from his house to the supermarket and back. Leave your answer in terms of Y. Okay, the supermarket. All right, now that we drew the diagram to understand the problem clearly, we can state like this. We can say unknown here. Unknown is, okay, let me, unknown. Okay, say here unknown. From the question here, the unknown is what we're looking for. Usually, it is in the last sentence in the question. Okay, like in this case also, they say calculate the overall average speed. Okay, so we're looking for the average speed. So when I say SAV, to see the average speed. Okay, and then I'm going to write here the given. Okay, the given in the question. Let's see what we are given here. They said the distance between Joe's house and the supermarket, which is X kilometers. So the distance D. So D, the distance will be X kilometers. Okay. And then the question continues, says, he drives from his house to the supermarket at an average speed of y kilometers per hour. So the speed from his house to the supermarket, let's call it speed 1, okay? S1, which is equal to y kilometers per hour. And then the question also says that he returns, but with a different speed than from the supermarket to his home. He drove 1.5, which is 3/2 kilometers per hour. So we call it S2. Okay, so this is 3/2 y kilometers per hour. Now, here I'm going to write formulas. We're looking for the speed average. The speed average will be given by the total distance. Okay, total distance over average speed. No, not over average speed, but over elapsed time. Okay, elapsed time. Elapsed time. Okay. Now let's do calculations. I'm gonna move this a little bit over here. Calculations. Okay, what do we know from the question? Okay, the formula we're going to do is over the elapsed time, but we do not have any time listed here, neither on the unknown, neither on the given. But the time is somewhere here, because we do know that the time is given by distance over speed, right? So in the diagram here, the times that Joe took to leave from home to the supermarket wouldn't be T1, the times from home to the supermarket will be X over Y. Okay, because all right, X over Y. Hour. The times expressed in hours. Now, the time also Joe took to leave the supermarket to his place is also will be then X distance, because the distance is the same. Distance don't vary, will be the same distance because the question says it takes the same roots. So X over 3/2y. That's the distance, that's the time Joe took to leave supermarket to his place. Now, to find then the speed average, we will substitute these. So this is going to be the speed average will be speed av will be total distance, meaning distance from, because the question says the overall average speed at which Joe drove from his house to the supermarket and back. Okay, the speed from the Joe's house to the supermarket and back. So this will be X plus X. So it's going to be X, the distance from home to the supermarket, and then from the supermarket to his home. So X plus X all over what? That's the total distance. The total distance over elapsed time. The elapsed time also must take, or the time that it takes from his home to the supermarket and back. So time to the supermarket was X over Y plus time it took from the supermarket to his place will be X over 3/2y. Okay, so now the speed average will be then, let's simplify this. This will be like X over Y plus, what is Y 3/2? Let's do it here. 3/2. Okay, that's maybe this one. X over 3/2y can be written like this. It's the same thing as X over 3y/2. So now, at the time that we have a fraction over another fraction, what we do, we multiply the first fraction by the reverse of the other fraction. So 2 times 2 over 3y. So we take the first fraction, which is x. Okay, this one x is the first fraction. And then we will multiply that by the inverse of the second fraction, which is 3y over 2. So now I take x times 2 over 3y. So x is also like over 1. Okay. So now we can simplify. We can work it out. This will be equal to move it a little bit here. This will be like 2x over 3y. So now we can simplify that. This is like 2x over 3y, all under 2x, because x plus x makes 2x. Then this will be, now we can work out a common denominator over here. Look, we have like y there plus, okay, I think I need space. On my right, like this. So equal, yes. We have like y here plus 3y there, and then that x and that 2x. So if I need to work out this, I need to work out to find the common denominator at the denominator of this fraction. So I can times here by 3 and times here also by 3 to make my fraction the same. And then this will be like all under 2x. Now let's move a little bit. Now the speed average will be SR will be equal to, at the denominator we have now 5x over 3y, all under 2x. Again, the same rule of a fraction over another fraction. We will multiply the first fraction by the inverse of the other. So that makes 2x times 3y over 5x. So now 2x can be written like 2x over 1, okay? Because this is like the main, this is the numerator, and that's also another fraction, a denominator. So that's another fraction, the denominator. So now we can multiply this. We can notice that we can cross x and x here, and then this will be 6y over 5, which can be written as 6 over 5y. That's the speed average. So I'm going to say here speed average will be 6 over 5y. Kilometers per hour, yeah.